Hi, this is Steve from GeoForge, and we're going to talk today real quick about some of our hydro analysis tools in Propeller. This is our TerraPilot platform powered by Propeller. And we've got four tools here for hydro analysis. The first one's going to be a flood level, flood to a specific level. So if we know that our water that's sitting on site, which there is actually some water in the LiDAR set here, in this pond at about 12, I believe about 15.1 feet right now, or 12.1 feet, my apologies. What we're going to do is we're going to say, okay, based on forecast models, we expect a major rain event. We're going to add 6 feet of water. So let's go to 18.1 feet. And what we're going to show is where that water is expected to come up because we're flooding this area to that level. As expected, we see it in our low areas here, in our planned retention pond here, and in our existing water here. We can take these regions and download the outlines of them as a DXF. So if we want to import that into a surface model as break lines, that would be the use case of that. So this is just a flood level, so that we can model that after certain scenarios and take a look and see what it does. The next one is going to be surface runoff, and surface runoff is going to show basically a preferential flow across the entire map. Again, what we're looking at is we can see, for example, in this map, that we have a clear swale line running right through here. This is a LiDAR data set, by the way. And so we have a high level of accuracy on the surface despite vegetation being on the property. I'll show you that data set in a moment. But water's coming from this high spot. It's flowing down. It's hitting the swale line. We have a pretty decent amount of flow right here, and we should expect to see that represented with a swale. So if I turn off that preferential path, you can kind of see our swales in the surface. Sure enough, it is what we expect. And so we're getting a good idea of which way water is going to flow. Obviously, the overall flow is to lean it towards our low spots, and here they are. We can use this to really analyze a specific location, right? It's one thing to say, yes, water's flowing down a swale. Congratulations, you did it. But let's go ahead and put water in this drop location, and we'll see that where that water is expected to go based on that drop. And we can change the radius of that drop, but now we're getting really kind of into the weeds of water from this location. Which way is it going to traverse? We can do that by polygon. We can do that by circle. We can also adjust the radius and kind of tighten that up or make it larger depending on what the needs are. But we would expect the majority of the water go either this route here or this route here from these feeders. Okay, so we're going to turn off these for a moment and move to the next one. The next one is our catchment watershed analysis. I have put a measurement on here, a polygon, that's just inside the outside KML or target area of this project. And what we're seeing here is the preferential path of our water, right? And of course, once again, we saw our swale lines here, so we know it's going to travel down those swale lines. We could see this one here moving in. We've got water heading off the property this way, and then we have a lot of water draining into these ponds. What we can do then is pick an outflow point and compute from that outflow point. Let's pick this one right here. We can pick from that outflow point, and it will compute the surface area of where all the water is going to come from. So if water is going out at this point right here, where's that water going to come from? If we picked a different outflow point over here, for example, then we would expect the water that we're not getting at the top of that hill to come that way. And sure enough, that's what we see. So really, we've got a line right down through here, probably a little bit of a ridge that's going to decide which way the water goes, and either left or right, depending on that. And we're going to get that information from here. So let's turn that off. And then the last thing we have here is a direct rainfall event. And we have set this up. I don't think I'm going to, what I'll do is I'll pick another region and kind of show you what the setup is. But we're going to set a simulation length in hours. So this is really emulating a low pressure system coming in, a historical rain event. We're going to pick our maximum water depth and our simulation quality. This does take a little bit of time to run, so I did pre-run this, but I do want to show you that what the parameters are of this, and you could upload a CSV if you have historical data from a previous event that you had concerns about. This is the one I previously ran. It's the same general region. And you'll notice that we don't see much happening at all because we are at the very beginning of the rain event. The first drop hasn't fallen yet. But as we take this timeline and drag, we will see where the water will build and where that depth will go. So as that water continues to run, our sinks here are getting the most amount of water in those areas, and that's upwards of that 2.4 feet. So then as the rain has subsided, we get further on into the event, then these are the areas that we expect to have that standing water. Interestingly enough, as you see here, with a unimproved parcel overall, except for a few minor details like this planned retention pond, we actually have water standing on the other side of this power line. And so this is a great tool to use during our due diligence phase when we're looking at what we're dealing with on the property, but we also use these tools in a final verification phase. So that's the 4 major hydrology tools of the Propeller platform presented through the TerraPilot solution that GeoForge does for our clients. And as always, if you have any questions, you can email help@goterrapilot.com. Thanks and have a great day.